Hi guys, welcome back. Another day, another question. Today's question coming from Doppler effect. So, as you know, we are having your 30 seconds to try questions. Please get your exam pad to try. So, question 6 now from past paper 6.1, asking you Doppler effect. Other details, everything we are going to give you. But now, Doppler effect, write in words. This is our question 6.1. Please try. You have 30 seconds. What is Doppler effect? Get your time to try. Sorry, I should keep quiet. 10 seconds. If you need more time, you know what you're gonna do. Just stop video and then write it down. Last 2, 1, and time's up. So now Doppler effect is coming now. Doppler effect, all definitions here. Please write it. Just check your answer with this correct answer from memorandum and correct your answers. Let's give you a few minutes to try, just maybe 1 minute, to check your answer. Doppler effect definition is coming in this topic. We have Doppler effect. Only one, I think, so there are not too many definitions in this topic. So please try to memorize. Doppler effect, change in frequency of the sound detected by a listener. Because the sound source and listener have different velocities relative to medium of sound propagation. So this is our definition for Doppler effect. Okay, so now we can go to next question. Okay, calculations coming now. So what we are saying, to answer question, to make sure everything is fine, you can write it down what we know. So let's see, a policeman with speed detector is standing on straight section of road where the speed limit is 80 km/h. All right, the hooter of a car moving. Okay, source of sound is moving. Okay, on this section on the road with constant speed. We don't know how many meters per second, and waves of frequencies 400 Hz. Okay, wavelength of the sound is given. Wavelength of the sound is 0,80 meters. Okay, wavelength is given. Let's write it down. Wavelength is given. Wavelength. Okay, speed limit equals 80 km/h. 80 km/h. And then what else we know? Wavelength of the sound is 0,80 meters. We are looking for frequency. You know wavelength and looking for frequency. This one is not about just straight Doppler effect, just easy one from wavelength to frequency. Waves, topic waves. So please try first. If you know wavelength, how you can get frequency? If you know wavelength, how you are gonna get frequency? Your 30 seconds coming now. Please try. Formula box you can use, of course, and from formula box you can check. For this lesson, maybe you can come with your exam pad and formula box. I think it's gonna be much better. From past papers, just you can use formula box just to try. All right, time is over. Let's continue. We can calculate frequency by using this formula. V equals F times wavelength. So V is equal speed of sound, 340. F times 0.80, wavelength is 0.80. Frequency is equal to 425, 425. So this one is our F listener, detected by the policeman, because getting this wavelength, so policeman just getting 0.80 meters wavelength, so it means frequency is 425. Next question now. Now they're asking you, car is moving over speed limit or not? That's our question. So 80 km/h is speed limit. So what we are gonna do, we will get the speed of the car by using Doppler effect, and then we are gonna say over limit or not. Okay, please try first, and then we are gonna explain. Remember, frequency of listener is 425. From 6.2 we calculated. All right, 425. F listener is 425. Okay, please use Doppler effect formula and then get speed of the car. Yes, last 2 seconds. Let's try and time's up. Okay, so now we can calculate speed of the car. How we are going to calculate? For photoelectric, sorry, not photoelectric, it is coming next period. We're going to maybe study this. So Doppler effect, we are using two important things. This is source of sound. We are saying S, source of sound. This is listener. What we know for this question, we know VL, we are going to calculate. Okay, we don't know that, sorry. VS equals what we heard, policeman speed is standing on straight section. So it means VS, speed of source, equals 0. VS, oh, sorry, source, we are lost. Okay. Listener is policeman. Okay, source of sound, like a car is coming, source of sound is coming, and listener is here, policeman is listening, so VL equals 0, policeman, just 0 velocity. VS, speed of car, we are going to calculate. And what else we know? Fs is equal to 400 Hz. FL, we calculate in question 6.2, FL is equal to 425 Hz. And what else I know? Speed of sound is equal to 340 meter per second. This is our formula for Doppler effect. This is our formula Doppler effect, but we have different cases, different one. First one, if they are moving to each other, our formula is FL equals V plus VL. And we know what is V, what is VL, what is VS, right? Plus minus Fs, if they are coming closer to each other. So they are moving to each other. Maybe one stationary, otherwise, but they are coming close to each other. All right, maybe both of them moving to each other. Maybe one is moving to another. But if they are coming close to each other, so we are using plus minus. All right, this formula just plus minus. But if they are going away from each other, V minus VL and V plus VS. Is it clear? So we are using this way. So now we are not using this one. We are using only this formula because we know car is coming closer to policeman. All right. So 340 plus 0, because I know VL, stationary listener, is 0. And then V minus VS. VS will calculate. And then 400. So what was the FL? They didn't write here. It is 425. 425 equals 340 over 340 minus VS. From now, easy to calculate VS, right? Just making cross multiplication from now, maths. You can calculate it. You are getting 20 meters per second. But our speed limit with kilometer per hour. So from meter per second to kilometer per hour, I should calculate. How can I calculate? Times by 3.6. Why 3.6? Because when you calculate kilometer per hour, meter per kilometer divide by 1,000, and then so divide by 1,000, and then seconds to hour, just when you calculate 3,000, okay, just long way we should explain, we can explain. All right, we can use this way, meter to kilometer, 0,001, and then 1 over 3,600, because 1 second, 1 over 3,600, 60 times 60, 60 minutes, 60 seconds, 1 hour. So, or we can show like this, 1 over 1,000 kilometer, and 1 over 3,600 hours. When you just change this, 3,600 over 1,000. It is in just converting to kilometer per hour. So we are using that way, and then you are getting 72 kilometer per hour. But from kilometer per hour to meter per second, it's much clearer. Kilometer per hour 2 meters per second. Let's show it that way. So 1 kilometer is 1 kilometer is equal to 1,000 meters, and 1 hour is equal to 3,600 seconds. So if you do that, as you see, you are getting 1 over 3.6. So from kilometer per hour to meter per second, as you see, 1 over 3.6, it means divide by 3.6. But if you are moving from meter per second to kilometer, let's show like this because they're asking like that. So kilometer per hour, so times by 3.6. All right, just you can keep in your mind like this, kilometer per hour to meter per second, divide by 3.6, meter per second to kilometer per hour, times by 3.6. I think it's much clearer now. So 72, it is less than speed limit. So it means it is fine, it can move, no punishment, nothing for this car. All right, next one, question 6.2. If they said, how affecting question 6.2 if car travels lower constant speed, slowing down, car is slowing down, what's gonna affect 6.2? What was the 6.2? Let's see, FL, right? 6.2 FL, yes. Speed of, yeah, frequency of, just frequency getting by listener. So just how affecting it going slowly. So that's our question. You have 30 seconds now, please try. If car is going slowly, frequency increasing, greater than, less than, or same? That's our question. Now, please try. You have 10 seconds now. Just try to get answer. Okay. Okay, let's start. Let's show our answer now. Less than. So if moving, okay, if answer says less than, so why? Let's try to explain. If it is going slowly, frequency getting less. All right, if getting slowly, moving slowly, frequency also getting less, because coming slowly, just affecting less. We can show with formula also. What was our formula? F is equal to V plus VL, V minus Vs times Fs. Fs still same. This side still same because VL is 0. Only changing this one. If it is car travels lower constant velocity, so this one is decreasing. For example, if we have 340, right? For now we have 70, it was 72. Or just we can give another number just to make it easy. Let's say if it is 40, now you have 300, right? If you make it less, 340 minus 20, for example, now 320. As you see, this all together increasing. This side increasing. If this side increasing, FL will decrease because inversely proportion, as you see, FL is equal to V plus VL Fs. This side number from 300 to 320 increasing. Just like if you have 1 over 2 and 1 over 3. X equals 1 over 2, let's say y equals 1 over 3. So, as you see, when this side increasing, other side decreasing. All right, so we have done question 6.4. Let's continue with next one. Now we have just write where can we use Doppler effect, sorry, in medicine for what? Please try. For this kind of, just like definition, we should learn, we should just make our list. Where can we use Doppler effect? Because they can ask this kind of questions also. Now asking in medicine. using in medicine, 2 examples they are asking from you. Okay, 5 seconds now. Please try, please write it down, and then we can carry on. Yes, time is up. So, answer coming now. Let's give our examples. Okay, you just take notes, take examples, and then we have done for today. Doppler effect, today's topic, it was Doppler effect. For Doppler effect, what we have learned today, if they are coming closer, we are using our formula, FL equals speed of sound plus speed of listener over speed of sound minus speed of source of sound times Fs. If they are going away from each other, FL is equal to V minus VL and V plus Vs times Fs. Done. All right. So see you next lesson. I hope everything is fine. I hope you are getting it. But just to learn, please try always. Just try to get, try to learn. All right. So next lesson, 19, day 19, we are going to learn electrostatics and electric circuits. See you next lesson, everyone. Have a nice day.